Hello, I'm Paul Beckwith. We're about mid-August and we have about a month to go, 4 or 5 weeks, say, in the Arctic sea ice melt as we head towards the minimum, which is generally reached in mid-September. So, as usual, it's an extremely interesting year, interesting summer for the sea ice melt. And the regime, if you like, of the sea ice is maybe comparable to very, very large number of floating ice cubes, essentially, in the center of the Arctic Ocean. And it's certainly, very, very fractured, very, very broken up. And there was recently also a cyclone which churned around and spread out some of the ice, caused divergence in the ice. And we saw a similar thing in 2012, which contributed to the record minimum that particular year. But it's, the ice is, the trend, of course, is to go to a blue ocean event with no Arctic sea ice, or essentially no Arctic sea ice, less than 1 million square kilometers. And we're trending there rapidly, but there's a lot of details that are intermingling. And I'm going to talk about some of those things. So basically here, this is the sea ice concentration. Okay, there's two maps. So we've got Greenland, the Arctic Ocean, and you can see all of the broken ice here on the facing towards Bering Strait. And you can see more details here. This is so 100% concentration, which is the sea ice area in here, and the extent is the total area here, where there's greater than 15% ice. So you can see, the ice is really being churned and messed up on this side. But even in the central ice pack, there's lots of fissures and cracks and openings. And the ice is not acting like a solid unit anymore. It's more acting like ice cubes that are floating, or large ice chunks that are just floating and mingling, in the center. And the loss mechanisms, interestingly enough, this year, there's still lots of ice loss coming down here through the Fram Strait. And there's lots of ice loss as the ice is trickling through the Canadian archipelago. This is a fairly recent phenomena, when there was very thick multi-year ice along this region here. It was very difficult. That kind of acted as a barrier to keep the ice in the Arctic Ocean, but that barrier is essentially being broken, so the ice is filtering now through the Canadian archipelago. So we have export of ice in the Fram Strait through the Canadian archipelago. We also have melting from above, right, with the warm summer air temperatures, and we have melting from below with the water surrounding, going underneath the ice in both the Pacific side and the Atlantic side. Okay, so this is my, just a reminder, this is my website, paulbeckwith.net. Please consider donating to support my research and videos via PayPal. In Greenland this week, before I go and talk about the sea ice, I want to talk a little bit about Greenland and the tragedy that occurred there. So Konrad Steffen, who sounded the alarm on Greenland ice, dies at age 68 on the ice while he was working. There is on Twitter a hashtag, Konrad Steffen, lots of different posts and pictures about his work and so on, and I highly recommend that you have a look at it. This was one of the best articles that I could find, the New York Times. So he basically fell into a crevice, or I don't know if there was an ice bridge on the surface consisting of ice and snow that wasn't strong enough to support his weight, but there was a lot of snow and high winds, and he was about 100 meters away from the camp and fell into this crevice, and there was water at the bottom of it apparently, and and died, drowned. People at the camp thought he was in the tent having a nap, but he just never showed back up. So he's been working at this research station. He created this research station on Greenland 30 years ago. So he was 38 years old, and he did it for 30 years, and then died just last week. So police investigators said he'd fallen into a crevice and drowned in the deep water below. Jason Box, who I did meet at the climate conference in Paris, and other scientists were at this station called Swiss Camp. And he says the crevice or large crack was a known hazard, but he added that high winds and recent snowfall had made visibility poor and landmarks harder to spot. So everybody, people were working. They were installing a new weather station. Dr. Steffen walked off to perform another task, and the rest of the people there assumed he'd gone back to his tent for a nap, but when they finished their work, he was nowhere to be found. Not too long ago, in this part of Greenland, there were not crevices in that region. It was very solid and thick ice, but with climate change, Greenland is becoming more and more like Swiss cheese, and the surface is actually becoming a very, very dangerous place to work, it looks like. Okay, so here's an example of, this is a 2007 image on the Greenland ice sheet of a crevice or crevasse. I guess you say crevasse is a proper pronunciation. And if you fall in this sort of thing, these things can go down hundreds and hundreds of feet, and there could be water. In the summer they'll somewhat fill with water, or there'll be water at the bottom, depending on the drainage system. And if you're in one of these things, it's probably game over for you. Okay, so this is the Greenland Swiss camp. There's some images of the camp. Okay, so there's an aerial view from a drone or a plane, and these are a couple of the main research laboratories, and then all of the tents off here. This is the part of Greenland where it is. It's on the western side of Greenland in this particular region here. Okay, so there's all of these different images, and anyway, that's where it is. Okay, so as we lose Arctic sea ice, as the warming greatly accelerates in the Arctic, these glaciers are not solid anymore. We know that they're shedding lots of ice there's lots of meltwater going into the seas around them, lots of ice calving off, etc., etc. And working on areas that were previously solid seems to be a very hazardous thing to do now. Okay, so I'll get on to the Arctic sea ice. So if you Google Arctic sea ice graphs, you get this website, and I showed you, if you click on these images, it brings up a larger view. So I clicked here, and it showed you where we are as of August 13th, which was yesterday. Okay, so the ice has melted around the edges, and it's all going, the only stuff is left is towards the center. It wasn't that long ago that all the, the mainstream science, everybody thought that the only ice, when the ice did go, the only ice left would be around the periphery. But, a long time ago I said, well, that's kind of ridiculous. When the ice is, the last remnants of ice, I think, will be in the central Arctic basin circling the North Pole, and it'll just be slush and ice cubes and so on. Okay, and one of the reasons is this is much farther north. This is the North Pole, and this is the so 90 degrees. This is 85 and 80 degrees here in this circle. Okay, so the only ice will be in that region. Okay, so from Arctic sea ice graphs, if you look at the Arctic sea ice extent, it was dropping extremely quickly. And when it's dropping extremely quickly, I have lots of friends who tell me, give me day-to-day blows on every little blip, that happens. And then I didn't hear from them for a while, and I knew that without looking at the graph, I knew it would be flattening out here. It did that last year. Okay, the dashed line is 2012, the previous record minimum in September was reached in 2012. This is the average with standard deviations, 2 standard deviations, and this is the curve. So we were much below the 2012, and then we've flattened out. It's like a very large slope here, and then we flattened out here. Okay, so we've got about a month to go. So let's have a look at this. This is incredible. It was just working a minute ago. This is not good, because this is one of my key. Let's kill this one and try again. It was just working, and now it's not. Okay, so it kind of tries to explain what's going on here. One of the things is that as the extent decreases, the weaker ice is on the perimeter, and that goes fairly quickly, can give you a large slope. And then when you're left to more of the central stuff, the thickness of the ice is larger, it's harder to melt out, and that could be causing, a change here. Like I said, we saw this, a similar thing last year. Everybody here is proclaiming, okay, record low here for sure, and you just never know. We're learning all kinds of new things in the Arctic every year. So we'll go, this is the sea surface temperature anomaly. So around the ice is here. We've got really high temperatures, water temperatures. The scale is up to 4 degrees Celsius warmer than normal. That's the anomaly here, and this is the surface temperature of the air at the ice. This is a very interesting curve, the DMI curve. So if we look at and we'll get rid of this, if we look at the DMI curve, the Danish Meteorological Institute, here's where we are in 2020. Now, one of the things I'd like to point out is this blip here, this positive blip here, quite significant, and a smaller one here. If you go back in the previous years, you just don't see it, okay? It doesn't appear. And there's very good reason for that, okay? This is the daily mean temperature north of the 80th latitude line, north of the 80th parallel. Okay, and if you look at the map here of the North Pole, the 80th is here. Okay, so the DMI temperature data is in this region, and what it's showing is a blip here, which I've never seen before, and the reason is that there's enough open water now in this region that the air temperature above that open water can start increasing and be much higher than the melting temperature of the ice. So I think this is a significant finding. Okay, thank you for listening.